Okay, welcome to the Mathematics for Big Data class. Okay. I'm Sang-gu Lee at Math Department, and we will study the mathematics for big data in this semester. We will meet Tuesday and Thursday, and we may change the room from here to the one room nearby my office. Okay, this is my email address, so you can use whenever you want to contact me. And we like to use the information on this course from the recently offered the course at Harvard University Math Department, which is the Mathematics of Big Data, which you can find on this web address. Okay. And I already uploaded this information to you, and the syllabus on this. This Mathematics for Big Data course was offered now in spring semester at Harvard University, and I found it is suitable for us to follow those guidelines of the syllabus. So we will try to adapt those flow for this. Okay. In this class, we will discuss the various forms of data which exist and the mathematics used to describe them. Okay, and then we discuss three important aspects of working with the data, including data acquisitions, data analysis, and data visualization, and mathematics involved in each. So we will use the half of this semester to cover the mathematics which is needed to understand the machine learning and big data. Then we will use those knowledges to go through the contents of the big data. In order to deal with those data, we need a tool to be used. We need a computer algebra system. Now I introduce you Sage Math, which you can find in these addresses, and Sage Notebook server that you can generate your ID and password. Probably I may recommend you to use your ID on here. Shall we? Would you make one ID on Big Data 2016 here in Math 3 server, and make same username, use the same username, so you can all of you can use this Sage Math server, which is based on the Python language. And R also can be used in this server. And recently, National Institute of Mathematical Science in Korea built a parallel computing server on Sage Math with 13 pieces together. So this will be a very useful tool for your large size computation later. And also we have developed the statistics introductory statistics laboratory using the language R that you can practice in here, for example. And here for this is an introductory course. I have 2 labs on statistics. Here you can use this is a language which was made in R. So from this R, you can draw the chart and bar chart and the circle chart, or you can listen the lectures on statistics using R, and we can find the histograms, and we can find the mean and medians from these data. If you have different data or many others, then also you can find the mean and medians with this language, which is R. So, and we can find the variance and standard deviations and what quantifiers. There are many. Okay, here, so you can draw the graph of the things. And also, I have, this is a very introductory part of statistics. This is the second part. This is the second half of the introductory statistics books, including the random, the coin toss problems. If you try it as not 10, if you try it as a 100, then you will also see 100 random toss of coin, that you will see the front and backs have the chance of this made, and you can choose the 6 numbers from between 1 and 45, and you can also find you can also choose what 20 out of 1 from 105, like this. Oh, these are all made with the R languages to go through it. I recently published a paper on this laboratory on statistics, but since we need to know not only mathematical knowledge, but also we need the knowledge on statistics, and also we need the computational tool. So I will use the Sage Math server, which utilizes your knowledge on Python and R. So after that, yeah, we will use those knowledge and tools to attack the problems in big data. Mm-hmm. So this has all, it has everything in here. This laboratory was made in Korean, but yeah, you will easily find the many books on statistics with R. So you can also find the code for those without much difficulties. You can find normal distributions, and you can find what the chance, the probability, and central limit theorems, and the things. This is okay. Anyway, these are the things. So actually, you don't have to learn the coding, the basic knowledge that we will use in later if you go through these ones. And so, and also, yeah, you can go here to check how to use those Sage servers. Mm-hmm. And also, yeah, you will be able to find from the YouTube that how to use the Sage Math. There are hundreds of the free lectures related to the Sage Math and the R and the Pythons, and as well as lectures on big data. Mm-hmm. Okay. Okay. Now we may introduce what we're going to do and why, and what was the motivation to study the mathematical knowledge to attack these problems in big data. I found some information which will be useful for us. Okay, and I will introduce some of those in here. Okay, and also, yeah, if I have one experience long ago in 1993, which is now more than 23 years ago. Actually, this was the problem of big data at that time. Do you? Okay. Okay, I will show it later. Anyway, there are some trend in mathematics. There has been a trend. In 1872, the great mathematician Felix Klein introduced the Erlangen program. Here, he showed a kind of vision. He showed a vision to do work. In the year 1900, at the International Congress of Mathematicians at Paris, and David Hilbert introduced the 10 problems to work for the next years. And hundreds and thousands of mathematicians worked on these problems, which led the great development of mathematics in the 20th century. Henri Poincaré also showed a direction to work with for the 20th century. In the year 2000, the Clay Math Institute proposed the Millennium Problems, which has $1 million prize with it. They proposed the 7 problems for the prize, and one has been solved, and the last has not been solved yet. And this led the direction for the mathematicians to work with, and these kind of the work did the trend initiate the new activities for specific and problem solvings. These lead the new frameworks and new theory and new connections. I found an article by Peter at ETH Zurich, and he gave some answers. The title was How Mathematicians Deal with New Trends Like Big Data. He mentioned that Felix Browder, who was an American Math Society president, mentioned the most important area of bioassociation lies in the interaction between mathematics and the sciences. One major external influence on mathematics is the computer. So now so this with this statement in mind, we mathematicians try to find a way to deal with the new trends on big data. Big data comes based on the mathematics and applied mathematics and statistics. The analysis of big data is based on this. Big data means a massive amount of data, usually called big data if the size of the data is very big, like a terabyte or something. Okay, because we have a better measurement devices covering a huge range of fields beyond engineering and the natural sciences. A hope for high societal value and business values. Here, the modern data analysis analysis was done by Turkey in 60s on statistics, and huge data set also was dealt by many in statistics. And new data analysis was introduced. The method for new data analysis was made by Granovo and the Gunnar Carlson from the mathematics side. And large-scale data has been generated from computational biology, and the computational biology approach was made on these large-scale data on biology, like genome project. And all this has been, it's time to gather all this to deal with new scale of data, not only the biology, but also all over the world, including the internet-generated data. So the trend, the trend created this kind of trend. The research trend created the data science, the area, new area of science. In the past, demanding applications broadened mathematics, leading new fields such as applied mathematics and statistics and computational science. This comes from mathematics. Then, is data science really of the same order of magnitude? The answer is at least a major current trend involving a huge number of scientists. Okay, that's what it said. Then what is the main aspect for mathematics and statistics? Analyzing the data, efficient and optimal information extraction. How do mathematicians deal with this? How we do deal with to analyze the data efficiently in optimal ways. And this calls mathematics again. Donoho said the data analysis movement has insinuated itself into every branch of society, and the missing ingredient in facing those problems, it seems to me, is mathematics. So many told mathematicians that there are things that mathematicians can contribute in the area of data science. Okay. Then the next, the lots of other trends there are in computer, the numerical method and simulation, mathematical optimization, algorithms and graph theory and discrete mathematics. And these computers have helped to make a new way of dealing with this subject to go further. And the interaction between mathematics and science, like mathematical physics, math biology, and math chemistry, and this has been a new trend recently. And interaction between mathematics and the sciences, like mathematical modeling. Okay. The reason that I got interest on these are the Sungkyunkwan University has the BK21 mathematical modeling division for the last 7 years. We worked on the computational mathematics and numerical linear algebra and mathematical modeling. And now, when the mathematics was called by the new area of big data science, and we found a kind of chance that we can contribute our previous knowledge to an experience to make a bridge from here to the data science. That's why we offered the course, and we will start Okay. And now we summarize what we mentioned. Historically, neighboring area of applied mathematics and statistics and fields and communities has split so far. So when mathematics, some mathematicians went to the applied mathematics and statistics area, they have lots of things to do in their own field, so they didn't care much about the combining those. So it has been split recently. But in the big data science, then can it be avoided? Can we get together again? Okay. And also interaction and communication with external disciplines. Is it creating new conceptual frameworks? Or what's the central part of math? What is the central part of mathematics? How to respond to all the needs in a huge amount of applications. Should we lead or co-lead collaborative effort? Okay, in these applications, and can we improve the communications within and across the border of mathematics? Okay, these are the things that we have to find the answers, and we have to try. Usually, mathematicians used to have lots of problems in their own, so pure mathematician actually need not much to go to the applied science and applied mathematics. But these days, everything's emerged in once, and the job market has been changed a lot. So now mathematics also started think to communicate with other disciplines, including computer science and statistics and biologists and many others. Okay, so we're going to start with the syllabus. The original syllabus had the title with Applied Linear Algebra and Big Data at Harvard, and the textbook is The Mining of Massive Data Sets. And this is a free ebook that you can freely download. So I already uploaded this textbook in our iCampus, so you can download it, so you can bring in your laptop or mobile device, those three. What I found, these books, these use a lot of mathematics to understand, and which comes from the calculus, multivariate calculus, and many things from, a lot of things from linear algebra, like the title of the course indicated. And it used the statistics and also the computational tools, class tools, including many things and many different languages. But I found the Python and R are the common and the most adaptable languages to be used in the data science now. And also, you need the knowledge of the engineering mathematics as well. Since we are in the graduate, you are in the graduate courses already, so I expect you must have been through calculus and linear algebra and some statistics and engineering mathematics. And most of the engineering mathematics part was covered in mathematics already, except some applications. So this deals with the multivariate calculus and linear algebra and differential equations and complex variables and some more with lots of applications. So anyway, we now, but we will check that we will review the materials that will be used in the study of big data in this course. And I found the SageMath can utilize Python and R and any other languages, including MATLAB and Octave and many others. So we will use the cloud computing server SageMath for learning Python and R and many others as well. So we will cover that. Okay. So homework will be assigned, and you are encouraged to post any questions and homework related or others to in iCampus Q&A section on the course webpage and I encourage you to collaborate together, and discussions and exchange of ideas are essential to doing this type of academic work. So we strongly encourage you to discuss and work on homework problems with other students. But each of you will submit your own homework set through the iCampus homework box. Okay. Yeah. In the case of assignment requiring programming, and you can use the code that I will introduce you, but you can make changes on it to make your own code for your own problems. And your grading will be based on your participation in those learning process and your homeworks and the final exams, or maybe final project. Okay, you can find on me and what I have done and what I have interested in ResearchGate or scopes elsewhere or from my own homepage. I have worked mainly on the theory of matrix from the theoretical view, structural matrix theory. Then I improved it to the combinatorial matrix theory and numerical linear algebra and computational mathematics and mathematical modeling. And so in this semester I will use most of my knowledge on the matrix to build up your background to attack your problems in data science. Okay, like this is what I mentioned. I've started from the matrix theory, and I have used heavily on the mathematics through the internet, and I have worked on the mobile mathematics, and I have developed several smartphone apps, and now recently I have worked on the 3D printing with the open source softwares, and I also have an interest on the history of mathematics to find the new trends of the 21st century mathematics. Okay, these are the things that I have made from my office last year for 3D printing, and I have used my own code to create this object, and now I'm thinking how to use those computational skills to deal with the big data. With those, we have the some national award, and these are the things that we're gonna learn in this semester, and these are the kind of contents has been covered at Harvard University, and this is what we'll start with. Okay. Any question before we start the content? Okay. This is a syllabus which was given from the other the courses which is similar to us, and they covers the linear system of equations and eigenvalue problems and eigenvectors, and PCA, principal component analysis, and singular value decompositions, and introduction to data mining, and pattern analysis, and cluster analysis, but this is unsupervised learning. Actually, this is an independent one semester course for the graduate student in biostatistics and supervised learning. This is going to be your project, and each of you will find a project to practice your knowledge in your problems, and modeling and prediction. And in order to do this, the mathematics what you need are this. For the linear system of equations, you need to know how to find the least square solution when it has no solution, or it has too many solutions. Then you need to find a best solution that you need for any type of, any size of matrices. And for the eigenvalue problems and for the eigenvector problems, you need to find how to find the largest eigenvalues in an effective way, and how to find the second largest eigenvalues in effective ways. And those kind of ideas will lead to build up the Google's PageRank algorithm, which is a power method actually, and some theory on non-negative matrices, and Perron-Frobenius theorems, and Perron vectors, and those others. And matrix factorization, you need to know how to factorize a given matrix in a product of lower triangular matrix and upper triangular matrix, which also can be written as LU or LDU or LDL transpose. Okay. This is a special type of LU factorization, and these eigenvalue, the properties of eigenvalues and eigenvectors are used to factorize a matrix as a unitary matrix and the lower triangular matrix, the product of those. That's called the QR factorization. And the pseudo inverse can be found by using singular value decomposition. And in order to do this, you need to know how, the knowledge of normal matrix, and also the knowledge of right eigenvectors and left eigenvectors of given matrix. And the polar decomposition and Cholesky factorizations comes easily from these knowledges. Then, and Jordan canonical form of a given matrix are needed, because when you attack a large size matrix, we don't want to deal with a very complicated matrix, so we want to find a unique, simple block diagonal matrix which has the most of the properties of the original one. Then we can save a lot of computational time, which is very important when you have a large data. And in order to find the generalized Jordan canonical form, we need to know about the generalized eigenvectors, because not every matrices are diagonalizable. And since we are dealing a lots of data, so which is a kind of discrete structures, so we need to have some knowledge of making a structure that we can use a computer to attack. So from the discrete data, we need to know how to build up a relating matrix, which we can use the knowledge on the matrices that I mentioned earlier. So from the given data or data structure like a graph, and then we should know how to generate the adjacency matrix from the given data or given graph, and then we can then we use the matrix properties of this adjacency matrix or Laplacian matrix to analyze the property of the sparse data. And also, this Jordan canonical form can be used to understand the matrix functions, like matrix by using the matrix explanation like this. So now we not only think about f of x, little x, we can also think about the matrix function, which is not only this of x. We can also think about this where a is n by n or n by n like this. Usually I like studying like this. This is called the matrix function. So if we understand the Jordan canonical form, we can define a matrix function like what we did on the calculus for what Maclaurin or Taylor expansions of given functions. So every function, every continuous function can be written as polynomials. Like we can use the same thing for the matrices as well. Okay, so we can expand our knowledge for that, which is needed. And also we need linear ordinary differential equations. That's why I mentioned the knowledge on engineering mathematics. So we need to find the solutions for the differential equations. And that will, and also Gram-Schmidt also normalization process and Hausfeld transformation is needed to go through this. And low rank approximation also can be easily drawn from this matrix factorization and the properties of eigenvectors. And also we need to know how to solve this generalized eigenvalue problems like this. Okay, and all of these are used in ODE and PDEs as well. So these are the kind of background. So we will spend half of our semester to go through this. While we are going through this, you will try to find your problems to attack. So you will try to write your project proposal before the midterm exam, and then your project proposal will be graded and then revised to really start just after the midterm examination. Okay, and I already gave you the first homework, and read all the notices and comment that I give in Q&A and the materials that I supplied, then go through it, and then add your responses in Q&A. And in particular, write about yourself in a short way, biograph, short, and your motivation to take this course, what you like to learn from this course before the class. So who gave the answer before you come to the class in Q&A? 1, 2, and 3. So only 3 of you will get a credit for your participation of your first class. That's the way that I give a point on grading. So for those who didn't do it, since we still have 15 more minutes, so it's time that you fill out those forms before I start to grade your participation. And yeah, so we will, yeah, the mathematical content that I have mentioned are from these 4 courses, basic math courses. So yeah, I will try to explain as much as I can in an easier way, so you can understand easily. But some of you may know it already well, and some of you may be new to those concepts. So try to communicate to fill the gap. So at least you understand what's the concept and how you deal with the problems, and particularly for a simple, smaller size problems, how you can really deal with it. For example, I expect you to find the Jordan canonical form of a given matrix of a small size, and I want to expect to find the QR factorization of a given matrix yourself. I expect you to find the eigenvalues and eigenvectors for a 10 by 10 matrix. At least everybody should be able to find it and explain how you found it. That's what I expect, like others. Okay, so in the next class, I will start from the linear system of equation to introduce your LU factorization and least square solution and power method and Google page length. Okay, and there are more, but here what I'm going to so most of here the communications. Notice here I have uploaded some materials like this. I have uploaded my lecture note that I showed here, so you can see it. And also I have uploaded what the Korean version and English version of the Google's PageRank algorithms that you just try to go with, and you try to explain if you can do it, and upload it even for one paragraph explanation to start with, and so before you come to class, then it will be helpful. And what else? And the others are, and actually this is one. Actually, this is my paper in 1994, and here where is the English? This says English abstract. Actually, 23 years ago, I needed to compute the 25th power of this 25 by 25 matrix. At that time, there was no computational tool. I had to use the Fortran language to compute this. Actually, at that time, I felt it is a big data for me. Yeah. But actually, I was successful to do the computer and to draw the conclusion on the transportation problems in Korea. And what I did was, this was the old highway system in Korea at that time. And my analysis gave, if there are many plans to build up the highways, and all the congressmen want to build up the highway that passes through their cities, their villages, but they had the only limited source of money, so they needed to give priority to build up. I analyzed the possibility, if we build this highway, what kind of benefits can be made. If we build up this highway, then what kind of change will be made? And after go through all this, I found if we build up the highway from here to here, instead of others like this and this and this will help the most with the least money. And it was proposed in 1993, and it was accepted by the government, and Cheonan Nonsan Highway was decided to build up first as a Minja highway. In 1997 they started to build up, and it was completed in 2002. Actually, this is a starting point of building up the highway, not like this is Gyeokjayang Highway in Korea. And from then, with this mathematical analysis of the 25 by 25 size matrix, and they started to build up the highway. What they did was, you will be able to read it. My conclusion was, in every holidays, there are two highways that passing through. That there is just bottleneck between Cheongwon and Daejeon here. So if we build up this short highway, then it can easily, the Honamsan comes from here and the Gyeongbusan comes from here. There is no bottleneck symptoms happened in here. It will make a very smooth improvement on the highway system. And that started to build up the highways here and here, and now. So in order to do so, we not only need the mathematical knowledge of the matrix power, but also we need to compute really on this. They asked me to use all the exit in Korea, which is more than 250 exit in the whole Korea, South Korea, and in that case I had to use a 250 by 250 matrix of that much of power of it, which is even not easy to type all those numbers in that. But anyway, so what I found was, we need to know some mathematical knowledge. There are many things that we can do if we can really do compute. And also the important thing is we need the data to make that matrix. I went to the headquarters of highway transportation in Seongnam to get this thick of book to collect the data to build up that matrix. And anyway, but these are the kind of a very simple example of using our data to draw a reasonable conclusion which can be used. Okay. Anyway, I have uploaded, as you see, I have uploaded some files, 4 books. Here, this is a book for statistics with R, and these are 2 books for Python languages. 2 in Korean, 2 in English, and there are what? Textbook. I already showed you how to find your textbook, and this is textbook. Okay, here, this is a syllabus, and this is a big data project, and I already here. I gave you a textbook here, so you can download it, so you can start to read it. And also, I have 3 of you did the homework, and others didn't the homework yet. So I expect you to do it before the end of this today. And I also gave you the linear algebra textbook, which is this is a 500 page books, that English version of it, that all the linear algebra concepts are in here. So you will, for those who didn't know the power method, then you will find the information here. Who don't know the singular vector decomposition, then you will find the information here as well. And so there are informations here, so you just go through it and make a questions and any comment and go through it and then raise any questions. So it will be answered before we start the next class. Okay, any questions for the first introduction of this class? Okay, then